Hello and welcome to lesson number 3 on anatomy and physiology for exercise at level 2. And a little bit of a different one today. We've got lesson A and B together and we're going to be looking at the muscular system. And as always, quick look at the learning outcomes. So we want to be able to understand the muscular system, okay? In particular, we're going to be looking at the 3 types of muscle tissue that are in the human body. And we're going to be able to define the characteristics of those 3 types of tissue. We're going to be able to describe the basic structure of skeletal muscle, and we're also going to be able to name and locate all of the anterior and posterior skeletal muscles. We're going to do 5.6, which is describe the structure and function of the pelvic floor muscles. 5.7, describe the different types of muscle action. And we're going to identify the joint actions brought about by specific muscle groups. And then finally, last of all, we're going to identify skeletal muscle fibre types and their characteristics. And it is a bit of a longer one today, so make sure you've got enough time. Make sure you've got your notepad ready and let's get started. Types of muscle tissue. So in the human body, guys, there are 3 types of muscle tissue. We have smooth, we have cardiac, and we have skeletal. Smooth muscle is automatically controlled by the nervous system, alright? So what that means is that we don't have any input. We can't use this smooth muscle as and when we want to, alright? It's normally found in the digestive system, also in the blood vessels and the urinary tract and reproductive systems. And smooth muscle works on its own, okay? We can't, it's not like our bicep, we can't just squeeze it and it works, so we can't just say, yeah, we want to pick something up, alright? Smooth muscle is looked after automatically by the central nervous system, and the reason it's called smooth muscle is that if we were to chop it in half and look at a cross section, it would appear to be smooth, okay? And that's what smooth muscle is, and that's the kind of places that you can find it in the body. We also have something called cardiac muscle. Cardiac muscle, as you can probably guess, the word cardiac means heart. So it's the muscle that makes up our heart, okay? And the difference between cardiac muscle and normal muscle, it's controlled automatically, the same as the smooth muscle, but cardiac muscle doesn't fatigue, so it doesn't get tired and it can keep working all the time. Obviously it's in our heart, so that's very important, otherwise our heart would stop working. And it doesn't get cramp or anything like that. It can keep going on and on and on. And you know, if it does stop, we're in big trouble. So that's what cardiac muscle is, and its main function is to pump the blood around the body. And then we have, I'm not going to say the most important type of muscle, but definitely the most common type of muscle in the body is the skeletal muscle. And the skeletal muscle is the muscle that we can move on our own. We have voluntary control of it, and it's striated muscle, alright? What that means is that if we were to cut it in half and look at a cross section on this one, we'd see lots and lots of little lines that make up the muscle. Okay, it's not like the smooth muscle in the digestive system. It's quite the opposite to that. And although these are voluntary muscles, they're controlled by something called the somatic nervous system, and essentially all that means is that's the nervous system that we control. Purpose of the skeletal muscles is they pull on our bones to help create movement. So through the tendons, they'll pull through the tendon, they'll pull the bone, they'll help us to move. They also resist the force of gravity and help us to stand up. Let's have a little bit of a look at the characteristics of muscle tissue, alright? All muscle tissue has the ability to stretch and recoil into shape. So it's like your bicep. We use it as quite a common example, but if you squeeze your bicep and then straighten your arm again, it will go back into position. It doesn't stay stuck. Okay, it's elasticy and it moves around. Muscles contract and they can lengthen. Okay, so they can contract and get smaller. They can lengthen and get longer. All right, and all of these muscles respond to electrical stimulus, and the electrical stimulus they respond to is the electrical current that our nervous system uses to send messages around the body. So they're all elasticy, they can contract, they can extend, and they respond to an electrical stimulus from the nervous system. We have the anterior muscles, and these are all in your manual, guys, as well, so we're not going to go through and name every single one, but we have the anterior muscles. Anterior means front, and it is going to be important that you know what all of these muscles are, because any of these could come up in the exam and you could have a specific question about one of these muscle groups in terms of its location or what it does or what type of movement it's able to create. Alright, so let's make sure we're aware of where all these muscles are. And posterior is another name for the back, and again, look at the manual and make sure that you know where all of these muscles are, because they're as fitness professionals, alright, muscles are very, very important, because you'll have a lot of clients, first of all, that want to become more muscular and become stronger, so knowing how they work and what they look like is very beneficial there. You'll also have clients that are interested in performance, so they want to improve their PB for the half marathon, for example. Okay, you need to know how the muscles work to be able to devise a plan that's going to help their muscles to get fitter, faster and stronger. Alright, even if you've got a client who wants to lose weight and you may not necessarily think muscular composition or the way the muscles work is important to them, it will be, alright, because we need to be engaging this system to help that person lose weight. And sort of following on from that, we're going to look at the structure of a muscle and what makes up a muscle, and then sort of how movement is brought about, the process that makes movement happen inside a muscle. But first of all, we're gonna break down this diagram, okay? And right there, right on the right side, we've got a tendon, all right? And just further along, it's not labelled, but you can see the bone. The tendon is what joins the muscle to the bone, okay? That's what the tendon does. After that, you've got the fascia, all right? And what the fascia is, it's like not a reef, but sort of like a very thin wall of collagen that surrounds the muscle and keeps it tight and keeps it in place. That's what the fascia does. It goes all the way around the muscle and keeps it nice and tight. We have the muscle belly. So the muscle belly is is essentially, as it really sounds, the belly of the muscle. So the more sort of dense, thicker midpoint of the muscle, that's the muscle belly. Then what we have the epimysium, okay? The epimysium. And the epimysium is a little bit like the fascia in terms of it goes around bundles of muscle fibres and keeps them in place, okay? That's what the epimysium does. It contains bundles of muscle fibre and it keeps them tight and rigid and it keeps them in the right place. We then have the fascioli, alright? The fascioli is an individual group of muscle fibres, and we then have the perimysium, which divides up, and again it's another sort of membrane-like material inside the muscle that divides up all these individual groups of muscle fibres, alright? If you were to look at the diagram there, in the middle, that's a group of muscle fibres, 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 and they're all divided up by this organism called the perimysium. We then have, inside the fascioli, an individual muscle fibre, and going around there is the endomysm. So the endomysm is what keeps that individual muscle fibre there. And right at the end, the smallest part of essentially a muscle fibre is we have a myofibril. So a myofibril are the tiny little bits that make up an individual muscle fibre. We've just got these definitions here broken down a little bit more in case you didn't quite catch any of those. So the fascia is the band of connective tissue, primarily collagen, that stabilises and encloses the muscle. There's the fascia there, just on the right. So it's a band of connective tissue that keeps the muscle tight and in place. The perimysium, that's the sheet of connective tissue surrounding a bundle of muscle fibres. So the perimysium, which is here, connective tissue surrounding a band of muscle fibres. That's the perimysium. The fasciole is a bundle of muscle cells, as we said. You can see here. Here we go. It's this one here. It's a bundle of muscle fibres. So it's not one muscle fibre. It's a bundle of muscle fibres. So all of the muscles are made up of different bundles of muscle fibres. We have the myofibril, which is the bit at the end, the tiny, tiny bit, really small, that essentially a group of myofibrils will make up an individual muscle fibre. We have the epimysium and the endomysium. Okay, the epimysium is a sheath of tissue surrounding a muscle, and the endomysium is again it's a sheet of tissue around an individual muscle fibre. Okay, so endomysium, which is here, goes around at the end of the process. It goes around an individual muscle fibre, and the epimysium is at the start, and it goes around the whole muscle. Okay, have a look through if that wasn't clear. But we've got the tendon, the fascia, which is a sheet of connective tissue holding everything in place, the muscle belly, which is the thickest, most densest part of the muscle there. We have the perimysium, which is connective tissue dividing up the individual fasciole, and the fasciole are bands or groups of muscle fibres. We have the myofibril, which is the very, very small part that makes up an individual muscle fibre. That's the myofibril, really, really, really small, really tiny. You need a microscope to be able to see them. We have an endomysium, which is the connective tissue around a group of muscle fibres. Okay, keep them all in place and make sure they stay where they need to be. And the epimysium is a sheet of tissue that goes around the whole muscle. A little bit like the fascia, not quite as strong, but however, that is the epimysium. So let's have a little bit of a look at the myofibril, because this is where the movement takes place. Okay, all movement takes place inside individual myofibrils, and what we have a sarcomere. All right, sarcomere is an individual part of a myofibril, so it's even smaller again. All right, and inside the sarcomere we have something called actin and something called myosin. All right, and they're two different fibers or filaments inside the myofibril. All right, and the thin filament is the yellow one, and the thick one is the red one. And what happens, as you can see here, red one and yellow one again. The red one, the thicker one, the myosin, grabs onto the actin, pulls it closer, and that creates movement. Alright? Going to go through it again. So you've got the red one. If we go right the way back to here, guys, so you can see. Okay, we have the thick one here. The red one is the myosin with all the little sort of, they're like hooks really coming off it, and they grab onto the yellow one, which is the actin. And when they grab on, they bring it closer, and that creates movement. So that's like your muscle contracting. The myosin's grabbing onto the actin, squeezing it all up, and that makes a muscle contraction. And that's how we get movement. Inside those muscles that we've just looked at, all right, we have two distinct type of fibres. They work in the same way. So you've still got the actin and the myosin, and the myosin grabbing onto the actin and bringing it closer together. That's still going on in both the fast and slow twitch muscle fibres, but they're very, very different. Okay, slow twitch are also known as type 1, and then you have fast twitch, which within fast twitch muscle fibres we have type 2, and we have type 2A and type 2B. So there's three in total. There's type 1, type 2A and type 2B. That's our three distinct groups of muscle fibres, and they all have their own characteristics. So type 1 fibres, they're red in colour, which means they've got a very, very good blood supply, and that's why they're red. And type 1 fibres are very good for long distance endurance type activities. It takes them a long time to fatigue, but they can't produce much force. So Type 1 muscle fibers are no good for an explosive effort like a sprint, but something like a long distance cycle or a marathon run, type 1 fibers are what you want. We've then got type 2B, right at the other end of the scale, okay? They're white in colour because they have a poor blood supply, and they work anaerobically, so they work without oxygen, whereas the type 1 fibers, they need oxygen to be able to work. And type 2 fibers, type 2B fibers in particular, produce a very, very high force, very explosive, very quick. However, they do fatigue and they do get tired very quickly. In the middle, we then have our type 2A. And type 2A will respond to training, okay? So they are classed as type 2, but how you train and the way you train will affect how those muscles adapt. So if you're doing a lot of long distance running and endurance type training, they'll become more conditioned to that. If you're doing lots of sprint type work, lots of weightlifting, then type 2B fibers is what they'll become more similar to. We've got the pelvic floor, okay, which is one of our other objectives for today. And essentially the structure of the pelvic floor muscles. The pelvic floor muscles are just beneath the lungs, okay? And they're a small group of muscles. Essentially, they're like connective tissue. So they go all the way through the... if you were to cross-section someone, let's cut them in half, that's the same way that the pelvic floor muscles flow through the body there. And they're underneath the pelvis. They provide support for the pelvic organs, and they also prevent stress incontinence, so to make sure that we don't sort of pop to the toilet when we don't want to. That's what the pelvic floor muscles do. They're also important for childbirth, so they'll make sure that the baby doesn't sort of fall out when it's sort of growing and getting bigger, and they'll also assist and push the baby out when it's ready to come. And they form a lower and the lower part of the inner unit. Okay, we're going to skip through the questions there because I want to get on to lesson B, and then we can look at the overview at the end and make sure that we've taken in all of the information there. And in particular, what we're looking at now, we've done sort of lesson A, we're now on to lesson B. Again, we're going to recap on anterior and posterior muscles. And we want to look at the different types of muscle action that can happen within the different muscles, and also identify the joint actions that happen in specific muscle groups. And that might sound a bit confusing right now, but we'll go through and break it down, and I'm sure that it will become a little bit more obvious to you. Just going to pick up on a couple of these as well while we're here. I know you've got your manual, but just so you guys are aware, the deltoids are the shoulders. Pectoralis major is the chest. Biceps brachii is our biceps. Internal obliques and external obliques. Internal obliques are just next to the abs. They're a bit more internal. External obliques are a bit lower and they're a bit further away from the abs. They're the external obliques. Rectus abdominals, that's the abdominal muscles. Iliopsoas, that is just down near our groin. Just there. We have the upper traps or upper trapezius, that's essentially just in between our neck and our shoulders, just there. We've then got the quads, which are our big muscles in our thighs. Adductors, which are just on the inside there of the leg, and they're responsible for adduction, hence they're called the adductors. And the tibialis anterior, which is the muscle just where the shin is, just there. We'll run through these on the back. Latissimus dorsi is the big muscles on our back. They'll be engaged through something like a lat pull down or a bent over row. Gluteus maximus or glutes, that's our backside. Hamstrings, back of the thigh. Gastrocnemius is our calf muscle. Soleus is just down near the Achilles tendon. Triceps brachii, that's our triceps, which are at the back of the arm. Hip abductors, so these are the muscles that are responsible for bringing the leg away from the body, from the hip. Trapezius again, from the back this time, you can see it's the same muscle, which spans over the front and back of the body. Rhomboids, they're just in between the shoulder blades, that's our rhomboids. And then the erector spinae, which is a bit further down the back in between the lats, okay? So, recap those, guys, and I'll whip through them really quick. But they are in the manual, and you will need to know what they're called. So just make sure you're aware of the individual muscles and where they are in the body. And all of those muscles are skeletal muscles, and they'll have a start point and an end point, and that is an origin and an insertion. So they have, essentially what that means is they have somewhere where they start and somewhere where they insert. They're connected at both ends of the muscle. They're not just connected at one end, also they'd be flapping around and all over the place. So it's important to know that they are connected at both ends of the muscle. Like our bicep, for example, is connected in down by the elbow, and it's also connected in at the top near the shoulder. Okay, the origin and the insertion. As the name suggests, the origin is where the muscle begins, and the insertion is where it inserts and connects on. All right. And the reason they have an origin and insertion is so that they can contract and pull on the bones and bring around action or movement. And the types of action they might bring around is they might shorten, they might lengthen, or there might be no movement at all. So when the, let's say the bicep again, because it's an easy example to use. When the bicep contracts, it shortens and it creates movement. Okay. When it relaxes, it lengthens, and that creates movement. And there are some muscles that have no movement. For example, our abdominals, when they contract, there's no movement, but they can hold us steady and they can hold us tight. All right? And I think we've touched on this in the past, but it's important to be aware that these muscles, they work in pairs. So when the bicep contracts as the prime mover, the thing that's moving first, okay, it contracts, and then the tricep will relax. They work in pairs, all right? Hamstrings and quads are the same. When the quad contracts, the hamstring is the opposite muscle, and it will relax. There we go. A little bit more on origins and insertions. So the origin is the attachment point of a muscle that remains relatively fixed. Muscular attachment near to the midline of the trunk. So that's the trunk of the muscle. So the origin will be in the middle of the muscle. It won't connect coming out of the side somewhere. It'll be at the end, in the middle. And you can see there, that's an example of some of the muscles in the. We're looking at the hamstring. It's not the clearest diagram, but you've got the origin there, and the insertion right down in the bottom. And the same, if you were to put your arm out in front of you again, we'll look at the bicep, you might be able to feel the origin just down there by your elbow, and the insertion is up at the top, and it's a little bit more difficult to feel. Types of muscle contraction. We have a concentric contraction, which is positive. That's when we shorten the muscle. All right. And eccentric is negative. That's when we when we're lengthening a muscle. Okay. So, for example, we've got a bicep curl here in the movement. When we bring that barbell up towards the chest, that's a contraction. When we lower it back down, we lengthen the muscle. All right. And that's eccentric. That's a negative movement. All right. And that's the two different movements. Bench press, for example, the bar or the weight is over your chest. When you push it up, that's the concentric movement. That's shortening the muscle. And the negative is when you bring it back down. Okay? Contrary to popular belief, if you're interested in weight training in particular, bodybuilding or strength building, then more damage is done to the muscle as we bring the weight back down. So the eccentric phase of the movement causes more breakages and more tears in the muscle fibre, which is what we're looking for. Because when we tear and break the fibre, it will build back. It becomes more stronger, and it becomes bigger when it builds back. Therefore, it's important to know that eccentric movement is what's going to help that to happen. Concentric, sure, will cause damage and it will help us, but eccentric also has a big role to play, which can also get ignored sometimes. And then we have an isometric contraction or a static contraction, and that's when the muscles stay the same length. For something like the plank, our abdominals would need to contract there to keep us steady and keep us in the same place, but there's no movement associated with that contraction. And we just want to look now at the roles of some of the muscles. So this girl here in the picture, she's doing a tricep extension. So if anyone doesn't know, tricep extension is where that elbow is going to stay where it is and the dumbbell is going to kick back. She's going to continue to move it back until her arm's in a straight position with no bend and sort of out towards a little bit higher than the buttock. She'll be aiming to get that dumbbell to there, okay? So the agonist, or the prime mover or agonist, meaning the leader or the muscle driving the desired action there, is the tricep. The tricep is the muscle that opens up that hinge joint at the elbow and pushes our arm back, okay? So the tricep is the prime mover. The antagonist, or the opponent, the muscle that drives the opposite movement, is the bicep, because the bicep is opposite to the tricep. Okay, the bicep closes the joint, the tricep opens the joint. So the tricep's pushing it back, and then when we return the rep, when we go again, so the second part of the rep, the eccentric phase of the movement, that's going to be our bicep controlling that movement. We also have something called a synergist, which means working together. So that's a muscle that aids a movement. So something like the posterior deltoid, so the back of our shoulders there, that's going to help us to kick that back as well. All right, it's going to assist. So it's working in synergy with the tricep. And then we also have a fixator. So a fixator muscle is something that locks down movements and is going to keep us steady. So in this movement, it's going to be the upper trapezius. So just to go through that again. Prime mover, the thing initiating the movement, is our triceps. The thing working against that movement is the biceps, okay? Triceps want to push it forward, biceps want to bring it back. Synergist, so the muscle that's working together, that's helping us to move that weight back, is the posterior deltoid. And the fixator, so the muscle that's keeping everything still and steady and making sure we're going to have a safe movement, that is the upper trapezius. Oh, that makes sense. What we're going to look at now is naming the muscles that contract concentrically to bring about joint actions. So, you know, if we're going to have elbow flexion, so that means at the elbow we are flexing, and flexing, as we know, means making something shorter. So the muscle that's going to be working there is the bicep. Hope that makes sense. So we want to have flexion at the elbow. So we want our elbow to flex, and it's the bicep that's going to do that, because it's the muscle that's closing that joint there and helping it to flex. With the knee, okay, we want knee extension, alright? So we want to extend the knee out. Which muscle? So what we're trying to do in knee extension, we're trying to push the feet up. If we're in a seated position, we're trying to bring our feet off the floor. That's what knee extension is. We're extending from the knee. And the muscle that's going to do that is the quads. Alright? And that's what's going to work there. What I'm going to do, I've given you an idea for the first two. I want you to have a look at the others while I put it on pause, just for a minute. Have a go at answering those questions. Make a note on your pad if you want to. Have a go at those, and when we come back, I'll give you the answers. Okay, so I hope you had a quick go at that quiz, guys. It is very valuable to have a go. So if you have fast forwarded through and not had a go at the quiz, please pop it on pause now and have a go, because this is probably the most important part of the whole presentation. You will get a lot from it by having a go yourself. However, for everyone who has had a go, we're going to run through some of the answers, okay? So first of all, we have hip flexion, all right? And hip flexion is when we are flexing at the hip. So we are closing that hip joint. So the movement there, so you can all imagine it and get the right movement into your heads. If you imagine bringing your thigh up towards your chest, that's hip flexion, all right? Because we're closing that joint there. We're flexing at the hip, we're bringing it up towards the chest, And the primary muscle that we're going to be using there is the hip flexors, alright? If you think about where the hip flexors are located, they're going to help us to bring that muscle up towards the chest. That's our hip flexors. Next one, we have shoulder adduction, alright? Shoulder adduction. So from the shoulder, we're bringing the arms closer to the body. We're adding to the body. That's shoulder adduction, alright? And if any of you there are using the cables in the gym to do a pec fly, then you should get the answer straight away, alright? Because it's our pectoral muscles that are bringing the arms in towards the body. If you just have a go at that now while you're looking at the screen, arms out wide, bring them in towards your body so they meet in front of your chest. Leave your right arm where it is and press your the right part of your chest. You can feel it's tense and it's working. You know, if you imagine being on a pec deck and do a few of those movements just now and then feel your chest, you should be able to feel it moving. That's shoulder adduction, and that's handled, in the most part anyway, by the pectoral muscles, alright? Right in our chest there. We have spinal rotation. So that's twisting from our spine, okay? Twisting at our spine, so we're rotating round, we're rotating the spine. And the muscles that are responsible for that are our obliques, alright? The obliques are the muscles, not the abs right at the front. The obliques are at the side, okay? They're at the side of the body, just sort of really covering up the ribs, coming in a little bit more low. If you twist to the side, you twist to the right, and put your hand against your right obliques and feel them, you can feel they're tense, you can feel they're working. If you feel the obliques on the left, they're relaxed, they're not working, and vice versa, okay? So that spinal rotation, that comes from the obliques. We then have spinal flexion, alright? And spinal flexion is really flexing the spine, narrowing the spine there. And what we're trying to do is, if you imagine when we looked at the postural defects in the last presentation, we're trying to really force a little bit of lordosis into our spine. That's spinal flexion, okay? It's flexing the spine. Muscles responsible for that, pulling our spine forward, are the abdominals. So if you have a go now at just pushing your lower spine forwards towards your tummy button, then feel those abs, you can feel they're tense, alright? You can feel that they're working, and they're the muscles that are firing and making that movement take place, alright? That's spinal flexion. We then have plantar flexion. Plantar flexion is quite easy. It's putting our toes on the floor and lifting up our heels, and straight away you should be able to, if you do that movement, plantar flexion, toes on the floor, lift the heels up, straight away you should be able to feel your calf muscles working there, alright? Lift them up off the floor and your calves will go tight straight away. If anyone's doing this in shorts, or you can actually see your calves, you can see them tense up straight away and rear up. Okay, next one we have on the list is a hip abduction. And hip abduction, okay, so from the hip, we're moving the leg away from the body. Abduction, we're taking away, okay? So the muscle there, if we had our leg straight and we want to take the muscle away, or the whole leg really, away from the body, the muscle that's going to be doing that is our glutes, alright? Have a go. If you need to stand up and have a go, and you can feel your glutes working. You can feel them firing and moving and taking that muscle away. Then the final one we have is shoulder girdle depression. A little bit complex in the name, but essentially it means pushing the shoulders downwards. And if you were to do a shrug in the gym, that's bringing our shoulders upwards. We're doing the opposite. We're pushing them downwards. We're depressing them. Alright? Muscles responsible for that are our lats, our latissimus dorsi. Okay? Feel them. Push your shoulders down. You can do it in the chair if you're watching. You can really feel the lats pulling down and moving at that joint. Okay? Now, I guess what I really want to touch on as well here, on all of these movements, these joint actions, okay, it's never the, say if we're looking at hip flexion, alright, it's not the hip muscle, alright, it's the hip flexors. If we're looking at what pulls the shoulders down, it's not the deltoids that are the muscle on the shoulder, it's the lats. If we're looking at plantar flexion, it's not only the muscles in the feet, it's the calf muscle, alright? So it's always muscles that are in and around and associated for moving that body part, but it's not the muscle that's right on top of the joint in the most part. So think about that. If you are keen to sort of grow in this area and improve your knowledge even more, do some research online, have a look at some of the other muscles that we've not covered here, and if you're an athlete, if you're training hard yourself, have a look at some of the movements you do in the gym, for example. If you're maybe a bodybuilder and you enjoy that type of activity, think about really what muscles are you engaging, you know? If you're doing a bent over row, yeah, it's for your back. Which muscles are being engaged? Is it the lats? Is it the rhomboids? Is it the rear delts? Okay? And what role are those muscles playing? If you want to go to the gym and have a play around, take down your normal weight a little bit, and on your reps, go a little bit slower than normal, maybe a 4 or 5 count on the eccentric phase. So if I'm doing a bench press, for example, it'd be 1, 2, 3, 4, 5 up, and then 5 again on the way down, and really focus on which muscles are working and which movements, and that should help you out with this unit. I hope it's been enjoyable. It has been a little bit of a scientific one, particularly at the end. What you should now be able to do is name and locate all of the anterior and posterior muscles. If you can't do that right now, have a little bit of a look at your manual and make sure that you're familiar with all of those concepts and all of those muscles there, because you are going to need to know them for the exam. If you don't, you might be in a spot of bother with that one. You should also be able to describe the different types of muscle action and identify joint actions brought about by specific muscle groups, which is what we've been looking at just on the quiz there. Hope you enjoyed watching. As always, drop me a line if you need anything at all. Next part of the series is going to be the nervous system, and I'll see you all over there.